Hello, Tiger Scientists. We are now going to embark on the fourth video of this unit, which is dimensional analysis. Yay! This is going to be pretty difficult for a lot of us, so we need to make sure to use this method in our conversions. Okay, what is dimensional analysis? Dimensional analysis is a way that we convert between units in our chemistry and our physics classes. Okay? Dimensional analysis is based on relationships between different units expressing the same quantity. Okay, so sometimes we want to go between milliliters and liters. Those are both units of volume. Okay, so they're expressing the same quantity, but they're going to be different values, okay, because we're having to convert our units. What is a conversion factor? A conversion factor is a ratio that we use in order to convert our units. Okay, so what are some examples? So there are cups to pints. So let's look at, let me get out of that. Okay, there are cups to pints. So we know that a conversion for cups to pints, that there are 2 cups in a pint. Okay, there are 2 cups in a pint, and we're going to express this in a ratio in fraction form, which would be 2.0 cups over 1 pint. Okay, and you may also see this as 1 pint over 2 cups. Okay, you can have it either way. Okay, these are both equivalent. Okay, just other examples that you may see are centimeters and inches, quarts and liters. I would know those. All of these, if I give them to you on the test, you'll be given the conversion factor in this form, and you would need to be able to put it in a form more similar to that. Okay? Okay, for setting up a problem, first we're going to talk about the relationship and kind of just how we start to set up a problem. Okay, first thing I always do is I always start with my railroad tracks, and you can draw better lines than I did. In this little spot right here, we are going to put our given units. So in a problem, you're always given units. There's a value that you know, okay? And we always put that here. Whatever the unit is, we always drop that down here, okay? Because in the end, we want that unit to cancel because we don't want to end up with that unit in our answer. We want a different unit, okay? And speaking of the different unit, we're going to put that up here on the top as the desired unit. Okay, so canceling units, pretty much what I mean by that is if I have one of my problems and here's my railroad tracks and up here I have my given units and let's say maybe it's milliliters, okay, I always want to bring that unit down and convert to my my desired unit. And if I want my answer to be liters, I don't want these milliliters anymore. So because this is in my numerator and this is in my denominator, they actually will cancel, so I no longer have milliliters and I'm left with liters. So that's what I mean by that. Okay, so let's look at a couple of example problems. And on this page here, I have it set up to where you have many railroad tracks. In your problems, you're just going to have one railroad track, but I wanted to separate it out so that you could see step by step what I'm doing in this problem. Okay, so it tells me that a person weighs 66 kilograms, and they want me to determine that person's weight in pounds. Okay, so my first step is always to say, hey, what was I given in this problem? What are my given units? What do I know? Well, I know 66 kilograms, so I'm going to put that here. The next thing I do is always drop down my units. Okay, so I drop down my units. That was my first step. Okay. My second step, and let me just actually really quickly transfer this here. Okay, my second step is to determine where I want to go. What unit do I want to convert to? What is my desired unit? Okay, in this problem, my desired unit is pounds. That's what I want to get to. So that's what I'm going to put right there. Okay, so 66. Okay, right here, my units are going to cancel. Okay, so my units cancel. Okay, my units cancel, and I'm able to use my conversion factor. So I'm going to use my conversion factor. Okay, this is something that would be given to you in a problem, but 1 kilogram is actually equal to 2.2 pounds. Okay, so I have 1 kilogram and 2.2 pounds. Okay, so I'm going to move up here, and I have 2.2, and I have 1, and 66. Sorry, I didn't want to put this all filled in previously, because then that would look even more confusing. Okay. All right, so my next step is to multiply multiply horizontally. So across, I want to multiply my numbers. So across, I want to multiply my numbers. So I'm going to multiply 66 by 2.2, and that gives me 145.2, and my unit that I have left is pounds. Okay, and then I'm going to multiply across the bottom, and that's going to be 1. Okay, so my final answer, I guess I don't need this box right here, but my final answer is 145.2 pounds. Be careful here, as you want to make sure you report it in the correct number of significant figures, which is going to be 2, so that's actually going to be 150 pounds as my answer, and that's my final step. Okay, so here this line meant multiply, multiply, and this line here meant divide. Okay, so one more slide, one more example that I want to give you. Okay, so it says I have 500, and then you see that decimal there, that means it has 3 significant figures. I have 500 milliliters, and I want to know how many quarts that is. Okay, so I'm gonna start here with what I know. Okay, I know that I have 500 milliliters, and I'm gonna bring down my unit. Okay, so that's what I know. Next thing that I'm gonna do is say, hey, where do I want to go from there? Well, I don't have the conversion from milliliters to quarts, but what I do know is I know how many milliliters are in a liter. Okay, so I'm going to go from milliliters to liters. Okay, and then I'm going to bring down my unit and think, where can I go from liters? Well, from liters, I can go to quarts. Okay, so I think I'm just going to use another one down here. That was milliliters, 500 milliliters. Okay, from liters, I do know to go to quarts. Okay, so I do know that conversion right there. All right, so I have, anyway, so I have quarts here. So now I have all of my units. You can see that my liters and my milliliters are going to cancel. Okay, so now I have all of my units, and so next I want to plug in my numbers. I want to use my conversion factors in this next step here. I want to use my conversion factors that I know or that I'm given on my test. Okay. This gets like extremely complicated, and I don't know that Mr. Neiman is smart enough for this. Okay. So I'm going to use my conversion factors in this step right here. Okay, so let's get to where we use our conversion factors. There are 1,000 milliliters in a liter. Okay, and for every 1 liter, there are 1.06 quarts. This one you wouldn't be expected to know. You should be able to get this. This conversion factor will not be given to you on the test. You should know your metric measurements. You should be able to do that and make that conversion without any help there. Okay, so last step is we multiply across. So we do 500 times 1.06, 500 times 1 times 1.06, and then we divide by the bottom. We divide by 1,000. So what's 500 times 1 times 1.06, it is 530. Okay, divided by 100 or 1,000 times 1, which is 1,000. And we get our answer is 530. And remember, we want 3 significant figures. So it's going to be 530 divided by 1,000. Sorry. Is going to be 0.530 quarts as my answer. Okay, so ignore this. I just didn't, I just messed that up a little bit. But my answer would be 0.530, and we need that last, because we have 3 significant figures, we need that last digit right there. Okay, so this video might have been just a little bit choppy because of some interruptions and some mistakes, but just kind of bear with it and see what you have here, and be ready for the next video, which will most likely be on graphing. Alright, so let's go Blackout Summit. Woo!